So here we have a problem that's a little bit like a combination of rules. And the reason why is this kind of looks like the power rule. Remember how we talked about the power rule where we have an outside exponent and then we have like a fraction inside? But we also have negative exponent. So I hate to say this, but remember, we'll go back to this. We talked about combination of rules. And then we did combination of rules of just product and quotient. That was from 5.1. And then in 5.2, we added the power rule. And now from 5.3, we added the negative exponent rules. Okay? Not going to add any more rules to this. So let's go over these. Some of these steps will seem familiar to you. Step 1. Anytime that we're doing combination of rules, make sure that every item, like a coefficient, constant, variable, has an exponent written. If you don't see one, we know there's an understood one, just write it in. The second step, we want to get rid of those parentheses, so we're going to do power rule. If you have an outside exponent, you can distribute to all inside exponents. It doesn't matter if the outside exponent has a negative sign. We're going to distribute. So make sure you distribute to all inside exponents, and if there's a negative side as like in front, like a coefficient, make sure you distribute to that as well. Third step. Now, because we're dealing with negative exponents, we're going to add the steps about removing negative exponents. We just talked about this in our previous video. Remember, make sure the problem is written as a fraction, circle all negative exponents, switch to the position of the circled exponent's base. If it was found on top, you move it to the bottom and vice versa. And then just remove the negative from the exponent. So now we don't have any more negative exponents. Step 4, this is where we do the product and quotient rule. We're going to do it together. With the product and quotient rule, I said always ask the two questions. Where do you have more of that like base, top or bottom? So that's where we put the base. And then to get the exponent, you ask yourself by how much more. And that's going to be a number for that base. Put it as an exponent. And then finally, if you have any coefficients or constants, try to simplify and reduce if possible. Okay. So, first step, make sure that every item has an exponent written. So notice, this 4 and this 9 don't have an exponent. And remember, I said every item. I'm talking about constants as well. So if you don't see an exponent, then we can slip in a 1. So I'm going to put a 1 here for that exponent, and put a 1 there for that exponent. Okay. Step 2, have a fraction, or have a parentheses. Let's get rid of the parentheses. How? Distribute. We only distribute the exponent to other exponents. Remember the power rule. We don't distribute to the base itself. We distribute to exponents only. There's no signs that we have to worry about distributing it to. So this would stay 4, but 1 times negative 2 is negative 2. 9, 1 times negative 2 is negative 2. Once you get here, we can now get rid of the negative from these. So how do we get rid of negatives? Remember, there's the 4 steps. We're going to circle the negative exponent, since the problem's already written as a fraction bar. We're going to rewrite the fraction bar and realize, this was circled, so I get to move this base. Found on top, it's now going to go to the bottom. When I move the base, remember I said the negative can go away from the exponent. And then this, circle, but notice this one was found in the bottom, so we can now move it to the top. Okay. When you switch the position, we can get rid of the negative from the exponent. Then we're going to try to do the product and quotient rule, but that means that we had to have like bases. Notice we don't have like bases. We have a 9 and a 4. So we can skip asking those 2 questions for product and quotient rule. So then all we need to do is our final step. simplify any coefficients or constants. You know what 9 squared is? That's 9 times 9, which is 81. And you know what 4 squared is? That's 4 times 4, which is 16. This cannot be reduced because I know if I factor that out, that'd be 3, 3, 3, 3. 16 would be 2, 2, 2, 2. Nothing but 3's, nothing but 2's, nothing reduces. This would be your final answer. From here to here, notice we were able to get rid of the negative exponent. We were able to get rid of the exponent as well. Okay? So let's do some more of these types of problems where it's going to be a mixture of different rules. Maybe power rule or negative rule was the quotient rule. It's going to be a combination of different rules. Okay? So we're going to start with probably an easy problem, and then we'll work our way up. Just to get used to moving things, because we didn't talk about fraction bars too much in our last video. So let's talk about fraction bars now. Okay. We can get rid of negative exponents pretty easily, even if there's a fraction bar already written. We told you the first step to get rid of these negative exponents is make sure the problem is written as a fraction, which it is. Then circle anything that has a negative exponent, this and this. And then rewrite the fraction bar. Notice the A, its exponent wasn't circled. So the ones that were circled, you switch. The ones that weren't circled stays where you found it. So this was found on top, it stays on top. This was found on top, but circled, now we have to move to the bottom. When you move it, that's when you switch to a positive now. And this was found on bottom, but it was circled, so now we have to switch. Once I switch, notice it becomes a positive. Now this one was a simple problem because I didn't give you any bases that were the same, so we didn't have to worry about the product and the quotient rule. We didn't even have to worry about the power rule because there was no parentheses or anything. But let me give you one that has product and quotient with the negatives. So let's take a look at this guy. So the first step that you want to do is make sure that every item has an exponent. And they do. We have only variables and they all have an exponent, so we don't have to write in one. The second step is, do we have any parentheses? No. So we don't have to do the power rule because there's no parentheses. The third step, do we have any negative exponents? Yes. This and this. So remember, to get rid of negative exponents, once I really realized that we have a fraction bar, I circled my negative exponents. Then I realized I'm going to have to move some of my bases. So I asked myself, for the Z, was it circled? No. Found on top? Stays on top because it wasn't circled. How about this W? Was his exponent circled? Yes. Found on bottom? Got to move it to the top then. This W, was he circled? No. So then found on bottom stays at the bottom. Do not switch him. Because if you switch him by accident, then this really then becomes a negative. Don't do that. Only the circle ones you switch. And this Z, found on the bottom, needs to come up to the top because it was circled. Now notice this went to a positive and this went to a positive because I switched the bases. Now we have no negative exponents. So we can finally go to the product and quotient rule. We do have like bases, Z and Z, W and W. So let's ask those two questions. Question 1. let's start for z's. Where do we have more like base? Well, for z's, they're only found on top. There's none on the bottom. So where do I have more z's? On top. That's the only way I found them. So I put the base of z down. Notice I only put one base of z. I didn't put two, just one. Then I asked by how much more? Well, how many z's are up here? There's 8 here and another 2 here. So there's 10 z's on top. How many are down here? 0. So where do I have more? Top. By how many more? By 10, because there's nothing on the bottom to cancel them out. So notice I put a 10 there. Let's talk about w's. We have some here and some here. Where do I have more? Trick question. Notice on top, I have 4. Notice on bottom, I have 4. There's not more on top. There's not more on bottom. It's a tie. What happens when they're a tie? Actually, there's no w's. Because 4 will cancel out with the 4 at the bottom. Nothing left over for w's. They're gone. So this whole problem reduces down to z to the 10th. Do you need this fraction bar any further? No, because if you said there's nothing left at the bottom, you put a 1. But what's z10 divided by 1? It's going to be just z10 without the fraction bar. Okay? So we can do the product rule, the power rule, the quotient rule with negatives, as long as we go through these steps, 1 through 5. Let's get a little bit more complicated. Remember, because we've been showing you ones that didn't have any parentheses. So let's show you one that has parentheses now. Okay? So let's try this guy. So you can see it's getting a little trickier because the ones that we were dealing with had no parentheses. So this one we know we're going to have to do a power rule with this guy. Okay, so remember our steps. First, make sure every item, coefficient, constant, variable, has an exponent written. Yes? Yes? No. So we finally have one that doesn't have a exponent. Remember, even coefficients have an exponent. So if you don't see one, we said write in the understood one. Okay, remember what our step 2 is. Do the power rule. How do we do that? Distribute outside exponents, so all inside exponents, and any inside negative signs. So this will be distribute to this exponent, to this exponent, to this exponent, and here. Okay. So when I distribute, I multiply. So -9 times -2, negative times negative, remember, multiplication, tic-tac-toe board. Hopefully you realize it's going to be a positive 18. This times this, -10. 1 times -2, remember, only by exponents, not to the base itself, -2. And then some of us might have forgotten, how do you distribute this to a negative? Remember, I said, see if it's an even number or an odd number. If it's even, the negative will go away. If it's an odd number, then the negative stays in the problem. So this is clearly an even number. I don't care that it's a negative, it's still an even number. -2, -4, -6, they're all even numbers. So that means this goes away, okay? Because it's an even exponent. Now that we have this, what's our next step? That the parentheses are gone? Remove all negative exponents. So we do have some negative exponents. Here and here. You can see why I wanted to do the power rule first, because if you said, Well, that had a negative exponent I could remove, but the problem is, once you distribute, oh wait, it's no longer negative. So that's the reason why we always say do power rule before you get rid of negatives. So now I know it's this guy and this guy that I need to get rid of. The question is the problem written as a fraction bar? No. So place it over 1. We know these two are circled. So let's rewrite the problem by moving these two bases. You know that this 6 cannot stay on top because it was circled. So this base needs to go to the bottom. When you move the base to the bottom, we told you, once you switch the position, this will drop off to become the opposite, a positive 2. This C, found on top, but was circled, so it needs to move. Switch the position, bring it down. And this wasn't circled, so it stays on top. Okay. After we get rid of negative exponents, they're all positive now. We told her our next step after this is to see if we have product and quotient rule. The key for this, do we have like bases? I have a base of D, I have a base of 6, I have a base of C. Yeah, I don't have anything that matches. So I can skip asking those 2 questions. And then what's our final step? Simplify, step 5, any coefficients or constants. Clearly, that's a coefficient. I can reduce that. How can I reduce or simplify? 6 squared, that's 6 times 6, which you know is 36. So you should write your final answer as D, 18, 36 at the bottom, because that's where 6 squared was, and C to the 10th. Okay? So we were able to go through the 5 steps to make this simplified. See how complex that looked with all those negatives? See how much cleaner this looks now that we went through the 5 steps? Let's give you one more that's a little bit more complicated than this. And then we'll do our sample question. Oops, oh well. So of course it's going to have parentheses because we want to do one that has a power rule again. Lots of negatives. So you can see this guy, and a lot of people look at this and say, I can't do it, it just has too many things going on. You have same bases, you have negative rule, you have power rule, you have so many rules going on with this. Again, be patient and go through the 5 steps. So step 1, make sure every item, coefficient, constant, variable has an exponent written. So let's make sure everything has an exponent. Yes, yes, no. See, there's no number here. So if you don't see one, we're going to slip in that it's a 1. Okay? Every variable has an understood exponent of 1. Yes, no. Even coefficients have an understood exponent, so slip in a 1. No, so you're going to slip in a 1. Okay, good. What was step 2? Remember, do the power rule. Let's get rid of that outside set of exponent by distributing it to all inside exponents, and if there was any inside negative signs. So I'm going to take this outside exponent, and I only distribute to inside exponents and negative signs, never to the base itself. So distribute, distribute, distribute to the 1, not to the base. Distribute, distribute, distribute. When I distribute, we multiply. So keep the same base, remember? And just multiply exponents. So we're going to keep the 3, but we're going to say 1 times negative 2 is negative 2. Here, negative 3 times negative 2 is going to be a positive 6. Keep the same base of x. Y, negative 2 times negative 2, positive 4. Over here, Remember, keep the same base. 1 times negative 2, negative 2. 1 times negative 2, also negative 2. Negative 3 times negative 2 is going to be a 6. Notice we have no more set of parentheses. Okay? Next, we got these negative exponents. Remember what we're supposed to have done to get negative exponents? Make sure the problem's written as a fraction. It is. If you didn't see a fraction bar, we say draw a fraction bar and put it over 1. Next, we say circle any negative exponents. Once you're done circling, switch the positions of those that got circled. Once you do that, you can remove the negative from the exponent. So we have negative, negative, negative. The rest are positives. So you just draw a fraction bar again. Because this was circled, you gotta switch the position. So found on top, move it to the bottom. This was not circled, so it stays on top. This wasn't circled, found on top, stays on top. This was circled, so found on bottom, gotta move it. That way we can make it a positive 2. This x, gotta move it. Looks like we're moving a lot of stuff. This x needs to go up to the top now. Once I move it, it becomes positive. And this y to the 6, found on the bottom, stays at the bottom. Alright. You can see I have some like bases now. Notice I have x, x, they're a match. Y, y, they're a match, but nothing else, because there's no other 4s and there's no other 3s. So now we gotta remember, step 4, ask those 2 questions. So let's ask ourselves those 2 questions. 4, let's say x's. Where do I have more, top or bottom? Clearly there's no x's at the bottom, they're all on top. So x's will stay on top. So I put the base of x on top. By how much more? Well, there's 6 here and 2 here. Remember, if they're both tops, you actually add them. 6 here plus 2 here. They don't cancel out. The only way they can cancel out is if you have some on top and some on the bottom. So 6 and 2 is 8. How about the y's? Okay, where do you have more, top or bottom? 4 on top, 6 at the bottom. So we got more at the bottom. Now because some are top and bottom, they will cancel out. So you say 4 versus 6, there's an extra 2 at the bottom. So I put a 2 there. Then, this is still at the bottom. This is still at the top. Okay. When I ask my question here about where I have more top or bottom, and by how much more, you'll always will have positive exponents. By asking those 2 questions, you're not going to have negative numbers that we have to worry about. That's why I don't like the quotient rule too much now, because you have to remember, 4 minus 6 means that you would have y to the negative 2 on top, and then you would have to get rid of the negative 2. We already got rid of all negatives up here. So instead of doing the quotient rule where it's top exponent minus bottom exponent, ask yourselves those 2 questions. Where do I have more y's, top or bottom? Boom. That's why it's at the bottom and not the top. And then I can say by how much more, it's always going to be a positive number. Okay? That way we don't have to worry about negative numbers. So that's why those rules state ask those 2 questions. Once you do the product and quotient rule, then you're just going to simplify. How are you going to simplify? You know what 4 squared is? That coefficient can be written as 16. You know what this is? 9. Y squared. This is your final answer. Looking at this versus this, you can clearly see it is simplified.